Welcome to aminacademy.com. In fluid mechanics, let us discuss about flow through equivalent pipe. First, we will discuss about what is equivalent pipe. An equivalent pipe is defined as the pipe of uniform diameter having loss of head and discharge equal to the loss of head and discharge of compound pipe consisting of several pipes of different lengths and diameters. That means, if suppose the water is flowing through a compound pipe, that is in pipes of different length and different diameters are connected in series, and water is flowing through that, it's a compound pipe. Then we have to replace this compound pipe by equivalent pipe, that is this the length of that equivalent pipe is the total length of each pipe, and as well as the new diameter we have to find that in that pipe the water flowing is same as compound pipe. Now let us discuss about the formula of that equivalent pipe. Let L1, L2, L3 are length of pipes 1, 2 and 3 respectively, and D1, D2 and D3 are diameters of pipes of 1, 2 and 3 respectively. The pipes are in series connected. Now let length L is the length of equivalent pipe, that is length of equivalent pipe. Now therefore L equals L1 plus L2 plus L3, that is L is the equivalent length which is the sum of the three lengths pipe. The total head loss equal H, that is 4F1 L1 V1 squared by D1 2G for the first pipe. There is 4F2 L2 V2 squared by D2 2G second pipe, and 4F3 L3 V3 squared by D3 into 2G is third pipe. Here this is the total head loss by using three pipe formulas. Here equation 1. Assuming that frictional coefficient is same for all pipes. Now discharge Q, you know that continuous equation A1 V1 equal to A2 V2 equal to A3 V3. From that we know that Q equal to pi by 4 D1 squared into V1, that is cross area into velocity. For the second pipe here, that pipe is here. Now from that we can get it V1, velocity through first pipe is 4Q by pi D1 square, V2 is 4Q by pi D2 square, V3 is 4Q by pi D3 square. Now these velocities you have to substitute in equation 1, and this equation we get total head loss equal 4FL1 4Q over pi D square whole square, because D square V square, then V2 square is here, V3 square is here, that is 4FL2 V2 square, that is 4Q over pi D2 square whole square, 4FL3 4Q by pi D2 over D3 by 2G. Now in this common factor, that is 4 square is 16 and pi square is down, and as well as here D1 square in whole square is D1 power 4, here D1 is there, so D1 power 5. So we have the common factor is 4 into 16 FQ square over pi square 2G, that take out which gives L1 over D1 power 5 and L2 over D2 power 5 and L3 over D3 power 5. Let it be the equation 2. Now head loss in the equivalent pipe, we know that H equal 4FL V square over D into 2G, where F is a frictional coefficient, L is the common length, that is the equivalent length of that pipe, that means addition of that all pipes length, and V square is the velocity through the equivalent pipe flow velocity, that is D is a common diameter of the equivalent pipe into 2G, where G is a gravitational constant, and where V equal Q over pi by 4 D square. From that we can get it 4Q over pi D square. Now we are substituting V values, then total head loss equal 4F in equivalent pipe, 4FL over D into 2G, 4Q whole square, 4Q by pi D square whole square. Then this here 4FL, that is 4 square is 16, and Q square F pi D square, that is D power 5 comes here. That H equal 4 into 16 Q square F over pi square D 2G into L over D power 5, equation 3. Now comparing this equation, that is here we are using that total head loss is addition of losses in each pipe, that is equivalent to loss in common pipe, that is equivalent pipe. That is here we are having 4 into 16 FQ square over pi square 2G, L1 over D1 power 5, L2 over D2 power 5, L3 over D2 D3 power 5, which is equal 4 into 16 Q square pi square into 2G L over D power 5. It's the equivalent pipe, head loss in equivalent pipe. Here head loss in connected pipes, that is series pipes or series. Now common factor is cut both sides, then we have L1 over D1 power 5, L2 over D2 power 5, L3 over D3 power 5 equal L over D power 5. This is the equation for the pipes or series, as well as it is compared to the equivalent length, where L equal to total length, D is diameter of the equivalent pipe replaced by common length, common pipe. Now we will do an example to understand this concept. 3 pipes of length 900 meter, 400 meter and 600 meter and of diameters 500 mm, 400 mm, 300 mm respectively are connected in series. These pipes are to be replaced by a single pipe of length 1900 meter. Find the diameter of the single pipe. Then equivalent pipe we have to find. Use the formula L over D power 5 equal to L1 over D1 power 5, L2 over D2 power 5, L3 over D3 power 5. You are substituting the total length is 1900 over D power 5 equal 900 over, that is L1 is 900 over 0.5 power 5, because diameter of the first pipe in meter is 0.5, that is 0.5 power 5, 400 over 0.4 power 5, 600 over 0.3 power 5. Now we are calculating these values. Here look at here, that is here 900 over 0.5 power 5 is this, and this calculation here, this here total addition is 314776.1. then cross multiply D power 5 is 1900 over 314776.1. from that fifth power you calculate, we get D equal 3599 mm. Then this is we are converting in meter. No, this is meter, sorry, this is meter, this is mm, that is here our hand point here. D equal equivalent length of diameter is 0.3599 meter, which is converted to millimeter is multiplied by 1000. This is 359.9 mm. That is equivalent length is this. So far you have done one equivalent length problem, as well as we discussed about how to derive an equation for diameter of the equivalent length of the pipe. We have done. Please subscribe our YouTube channel.